Hey, I think we're back live. Let's make sure that everything is working, that the music is not too loud, that we're live here. I don't see myself, but that's okay. I think I want to see the channel. I want to see Twitch chat. Okay, as always, I'll be looking back and forth at the chat to see if someone said something. Muted myself here, so now I can get started. So yesterday we worked on this. We worked on the Pulumi .NET code in Pulumi CodeGen in .NET, where we had implemented a parser for the Pulumi configuration language, and that parser is basically a syntax tree for the whole program. So we have Pulumi programs expressed as PCL, Pulumi configuration language. We use Pulumi a little bit. I have a local build of Pulumi that can transform the PCL program from PCL using the PCL parser we have into JSON, so that other languages, in this case F#, can interpret it and transform it into a nice syntax tree like this. I didn't do all of these during the stream, so I went ahead and completed the program. I think I have all kinds of expressions now implemented. At least for what I hope to accomplish, these will be more than enough to build a language converter like the one we saw yesterday when we took YAML and converted that to C# to .NET. So I hope that I'll be able to do the same thing from here using just the syntax tree, and maybe we will be using also the types from the schema, because if we look at because we have the configuration language, if you look at the tests, we have a couple of test programs. For example, the basic AWS program, which makes up a bucket with a single index documented in it as the bucket object. Let's see. Yeah, this is the bucket object we have as index HTML. It's a simple literal value expression. It's just a simple hello world HTML. So this AWS Pulumi program is converted to JSON, and all the way down we also see something interesting. I don't know if I touched upon it last stream, but the plugins are the resources, the Pulumi resource plugins that were used to generate this program and their versions. So we will going to be using this information to retrieve schemas for the program, because right now the program we get here is purely syntactic. It doesn't know anything about the things that need to be deployed. For example, even though we defined the resource, the bucket resource, and gave it a property website which has a property index document, we don't know if those are actual properties that exist on the bucket resource. However, since we've used the Pulumi CLI to convert PCL to JSON, it means that it's gone through Pulumi, and Pulumi does the type checking for us. So we can assume that these attributes are type checked, but we don't only want that. I also want to have the types available when I'm converting. So what I want is to take the syntax tree that I have here, the syntax expression along with its like a resource. So here I have a resource type, which is basically the defined in the PCL program, and I want to match it with a resource that is defined from the schema, because in schema we also have resources. Let's see. So this is a resource defined by the schema, which describes all the possible inputs and all the possible methods and whether it's a component or not, etc., etc. So this is the description of the resource, and in the PCL, it's the resource declaration, right? So we will want to combine these two things to get a typed tree. And from that type tree, we can generate a C# program. Actually, we can start using untyped PCL to generate a C# program, although that probably won't be correct. But let's see how far we can go using just the syntax tree, and later on see how we can also extract types where possible. I hope that all makes sense. So here we have the types, and like I said, a program has a bunch of nodes, which are the declared nodes in the program, but it also has the plugins, the one that I just showed in the tests. And here, for example, it has the AWS plugin using this exact version. Now we will use this information later on when we want the typed information about the program. We will use this information to retrieve a schema for this thing. And luckily for us, Pulumi, the CLI, has a command for that. So if you have Pulumi package get schema AWS, it will actually retrieve a schema for the AWS resource provider using the latest version that it can find on my machine. If I don't have any version of my machine, let me show you. So I have Pulumi plugins ls, Pulumi plugin ls. I have two AWS resource plugins. One is latest 5.24 and one is a bit older. So when I do AWS Pulumi package get schema from my AWS, I will get the schema from the first one, the latest version, or if I have a version, I can specify it like this. So 5.10.0, and I will get a schema. The schema that I get here is actually in JSON. So that's perfect for what we have because we have a JSON parser. And the nice thing about this Pulumi command is that if I don't have the resource provider installed on my machine, it will install it from GitHub. So it will look up the plugin on GitHub, retrieve the asset, download it, and get me a schema. Now that usually takes a bit longer, but the next time you run it, because it has to download it, but the next time you run it, it will be a lot faster. So what I did here is I implemented a simple loader static class, schema loader, and I gave it implemented a function called from Pulumi, which gives you a result of either a schema or an error. And the only thing it does is that it shells out to the CLI. It shells out to this to get the schema, and the standard output will be the JSON. So we simply pass that to parse schema and we get a schema out of it. So this is a very nice and simple way to do it. Although I personally would have liked that we don't rely on the CLI. I want the .NET CodeGen tooling to be pure .NET, doesn't rely on the CLI to be present. But I think we can't really work around that because we will need Pulumi CLI to get our JSON representation of PCL, right? When we take a base YAML program and convert it to .NET, we will ask Pulumi, can you give me a JSON representation of that PCL to work from there? So today I want to actually write two things. I want to write a .NET CLI, a simple console project that does the same thing that convert does, except that it will shell out to Pulumi to get the JSON, and from the JSON we parse the AST, and from the AST we generate the C# program. I hope that makes sense. Let's see how far we can get here. Now, by the way, I'm not sure if I mentioned this, but all of this code is on GitHub. Hey there, Jimmy, how you doing? Hi there, guys. Let me show you the code real quick. So the code is here, Pulumi CodeGen.NET trying to do an experiment here for our hackathon project, because all of our code gen is written in Go, which isn't the nicest language to work with higher like more abstract concepts like an abstract tree, or it's just not nice for higher level types of metaprogramming. So I'm looking into how we can do it in .NET, because we actually have a .NET language support. Recently we've moved our .NET specifics to its own repository, which is nice, except that the language, Pulumi language.net, is the language plugin still written in Go. In the long run, I hope we could rewrite this also in .NET, which would be great, but it would also need to handle code gen for SDK generation and program generation, for which I'm making a prototype. But it will take a while, because like this tech is being developed heavily, and it's not something I can manage to do in a couple of days, but I can make a working proof of concept at least, hopefully. All right, so with that said, let's write this CLI thing. So last time I explained that if we start from YAML, we basically shell out to my local Pulumi binary and ask it to convert into a target language JSON and output that result into something somewhere, right? Also need this experimental. So what I want my CLI to do is, for the first part, to get the JSON, I want to basically be able to say, well, okay, this will run. I want to be able to say .NET or Pulumi convert.net and just give it out directory C# next or something like that. So it will check the current working directory. If I'm working with YAML, maybe we'll only do YAML. If I'm working with YAML, shell out to Pulumi convert, get the JSON, parse it as PCL, start converting the program. So this is the plan. Let's get on with it. So Pulumi CodeGen.net, make a new, let's make a new project. So make directory, let's call it Pulumi program convert. Let's do that. Name doesn't matter. I don't want to spend too much time on naming. Pulumi program converts, and this will be a CLI. So .NET new console lang f#. Now this will add a reference to the Pulumi configuration language, which in turn references the schema to Pulumi configuration language. All right, so it was added. There we go. Let me open a couple of namespaces. Open system, open, well, Pulumi configuration language. Or maybe I will do that later, but let's see. So let main args, which is a string array. Yes, the entry point goes here. .NET run. Make sure builds does not build, because it should return an int. That is my bad. 0. Okay, let me add it also to the solution. So sln add what we have in Pulumi program convert. Okay. I think I also have, because I already use CLI wrap from The schema loader, I think I can also use it here. Semi-wrapped buffered. Okay, so shelling out to Pulumi, meaning that when it runs, we will need to find the current working directory. So is that directory get working directory, or is that environment get working directory? It's been a while since I've made a CLI. Current directory. I think it's the same thing. Okay, let's go with what System.io suggested. So directory get working directory, and then it's not get schema. What I want to do here is assume we're running in a directory. Okay, let's see the files. So files here is directory get files pulumi.yaml. So don't want search option, so just get the files in the current directory. If not, I want to make sure that I have a Pulumi YAML file. So if not array contains pulumi.yaml, then fill with, or not fill, because you get a print fn current directory 1 else. Now we have a Pulumi YAML. Let's shell out to Pulumi and ask it to get us some JSON. Now it doesn't automatically gives us JSON through the standard output. It takes an out directory and writes the JSON to that directory, so we will need to read the JSON from that directory. And which directory that is, it's going to be something I could either put it in the current directory or put it in a temp directory. Yeah, temp directory is nicer, so use temp dir, something like that. Let's see if that's correct. Temp dir. Full name. So here I'll be temporarily using a temp directory that when disposed, when at the end of the call, function call, it will actually be deleted. Recursive is true. Well, it doesn't really matter, but basically use temp directory. Actually make it return something. How about that? So f, make it take the directory path and returns, yeah, and returns a string. So let's call that, let program JSON is this, and continue on with it. program is Pulumi configuration language, parser, parse program, and right now just gonna print fn all of the program. And be done with it. Now we'll do something about this here. If array contains files, like that. We will do something in here where we shell out to Pulumi. Alright, so far so good. So using the temp directory here, let's see, convert cmd is CLI wrap, convert, well, not Pulumi, actually I want my local build, which is fine. If later this gets into actual Pulumi, then it's okay. Let's find Pulumi. So it's in the home directory, which means get environment variable home. Home is not always available, so that's environment get folder path, which will be special folder, I think. Yeah, special folder. User profile, I think that would be the home directory, which is equivalent to just this part here, this tilde. So we expand the tilde so that we can get the rest from here. So hope that made sense. So once we find the home directory, our dev Pulumi, development Pulumi build will be, that is very close, Copilot, but not really. So that's .pulumidev /bin/Pulumi. That's the process, that's executable we want to wrap. Is it an exe if we're working on Windows? I'm not sure. Is it an exe if we're working on Windows? If in environment, oh, it just knows. I'm not sure if it's listening to me or understands that. Version. Is that how we check Windows? Okay, I will trust. Well, if it's Unix. If it's Unix, then this, otherwise it's Windows. Let's just go with that. I don't really mind because I'm just gonna demo this tomorrow at our hackathon demos. So it should just resolve to this and work. So local Pulumi dev convert language JSON out at my local direct path temp dir. So this is temp dir, which would be here. Yes, so this is the output. Okay, maybe make it return a result. How about that? And the whole thing returns a result. Why am I being a bit too strict about this? I can just make this return whatever. There we go. Okay. So we shell out to my local build, run a convert where the target language is JSON because that's what I implemented in my local Pulumi build. Set it out in the temp directory, execute. If we have non-zero, then return the standard error. Otherwise, just give me the contents of the file. Well, why stop there? Just get me the program. So this is program, and we will simply match program result. They say you shouldn't use the type of the thing in the name of the thing, right? I'll just say converted program. How about that? Match converted program with an OK program, in which case just print it out. And otherwise error converting program. And here I'm outputting basically the syntax tree, right? How can I make this a CLI? As in a local .NET tool. Is it back as tool or something like that? It doesn't really matter. Let me try that out. So I need the full path here. So .NET Run. Copy path. Let me run it from this directory. Can you do it like this? .NET Run project. And give it basically no variables. Okay, it said it did not find YAML in the current working directory, which makes me wonder what's the current working directory. So could not find it. Is this correct? No YAML, no Pulumi.yaml found it. It's right here. Did I mess that up? Get the files from the current working directory. Pulumi.yaml, it's right there. Because it's a bit dumb. The files are are the full paths. So need to actually get the file names, not just the full paths. Okay. Which means that this should do something now. Ah, yes, it says it cannot generate programs for JSON because I did not give it the Pulumi experimental environment variable, which should be easy to add from here. So here we wrap the dev command, and this looks a bit weird. It doesn't matter. Environment variables. With environment variables, it just takes an I read-only dictionary or a configure thing. Pulumi experimental. Set returns the builder, so do I need to ignore it here? Yeah, something like that. Let me make that nicer with arguments. Okay, that looks somewhat nicer. Can we have a read-only dict here? Oh, we have. Okay. Experimental. True or one, it doesn't really matter. Okay, I think this should do it. First, let's clear up this mess and run it. Hey, there we go. That's our program. Parsed and everything. So this is the syntax tree we get from parsing this YAML. If I change, I think I also have a configuration node here. Yeah, I have a config variable just to make sure that it actually does something. Let me remove that. Maybe it won't work because now Pulumi, oh, it can, it works. But now it doesn't have a yeah, it doesn't have the config variable. Okay, so that's a start. Now let's write it out as a generated program here. So Lumi.net, LumiCodeGen.net. After we have the program, we have to do something with it. Match the arguments, because I want the result. I want the CLI to tell me what to do with the program. So in this case, out, at least tell me the out directory. And if it didn't tell me the out directory, then it's just the current directory. Let's see. Out directory is match the args. So give it the out directory. Anything else? Actually, that is path combine. Okay, now we have an output directory, and
I woke up this morning. I made some coffee. That was nice. But then, well,
let's write out the content in there. So
I guess I'm here now.
let
But I don't really know what I'm doing.
converted is, well, I don't have a program converter yet, but as a start it's just sprintf program
Nice to see you around.
and not
Wonderful day.
not really F#, is it? We'll just call it converted program.cs, because I plan to convert it to actually to C# actually. So let's see how we can do about that. So basically we will change this line. We will change this line into make an actual C# program out of it, right? Okay, let's try that out. And by out, it's going to be C# next. How about that? Oh, it does not. Make the directory if it does not exist. If not directory exists, okay, it looks ugly, I know, but it's fine. We'll make it nicer later. Not like we're generating C# now, but that's okay. Back here, write it out to C# next. Again, it not found. What did I do? If it does not exist, what's failing? In write all text, it cannot find the path. Oh, what do you mean? It's, oh, it did work. never mind, I thought it errored out. Well, this is not C#, but this is the program. The one thing for sure is that the ordering of the nodes is not really correct, because config variables and local variables should be before resource declarations, then we have all resources, and at the end we have output variables. So let me work that out. Let me sort that out in the parser. The parser should take care of that. In the parser, once we have a bunch of nodes, let's sort them out. So sorted nodes, I can actually do it here. Sort by. Function sort by is ascending, so first node dot config variable is 0, local variable is 1, resources 2, and output is 3. I think that would work, except that I also need to make them list. So once I've written a function here, I don't like adding another function at the end, but it's okay. Okay, let's test that out. Back to JSON. Okay, let's see, config variables, then local variables, then the resources, then the output variables. That's nice, so that the program converter can just start writing them out in order. Now, I don't know if the resources are already ordered, because some resources might depend on other resources. And I don't know if that's in order or not, but that's okay. Yeah, so far so good. So far so good. Let's actually start writing the converter. So in convert, this is just going to be the CLI, so I want the converter to be in the configuration language. Converter, add it to the project. You can just open types, right? Now let's see. So we have let convert to C#, takes a program, doesn't return anything, right? Oh, it does return the string, of course. remind me. Okay, let's start out. System IO. And not sure IO, but definitely text. Because we're going to use a string builder. Is a string builder disposable? No. Okay. Let's add the usings. No, let's just builder end line. You get a string builder back. And join append. End line using system. And using Pulumi. And what else? Using system.collections.generic. And finally, ignore all of that. Append line. There we go. And at the end, builder toString. Okay, so for node in program nodes, do match node with, if it's a local variable, which is local variable. Okay, before implementing it, let's actually make something. So that's mutable. Yes, mutable indent. It actually knows what I want to do. That's impressive. End line. That is not bad at all. We can do a multiplication of this. Does that even work? I don't know if that works. No, that doesn't work. String. Init indent like this. So append line. Using Pulumi. and line. And another one, add indent and remove it afterwards. So let's see here, scope will take F, which is exactly what I want. So with each new scope we increase the indent by 4, and when we're done with the scope we decrease the indent by 4, so we go back. So append line tasks, and append line will be await deployment run async. Now it should start a new scope, append line, and this is at the end. Start a new scope, although I'm not a big fan, but return await, and this is not async. That's right, so this is the scope, and inside of this scope I like to call it begin scope for some reason. Okay, that makes sense. Now here for node in nodes, we can start doing things. So converter, convert to C#. Let's actually do that in the program convert. It doesn't know about the converter, which is a shame, but I can make it know. It builds, so it should be fine. Sometimes just need to reload and then it's happy. Yeah, now it finds it, so let's go to the test. Hey, that's more like it. Missing a couple of semicolons here, but that is a nice start. Is there a flag to create all directories in between? I don't know for sure, to be honest. Usually when I need to make recursive directories, I will use some fake libraries, like the fake directory ensure. I think it ensures that all directories are created recursively. Here, converter, missing semicolons here. A nice append line that has nothing, and we return await. So for each node, match node with Oh, did you write it for me? No, not right. Resource, I would say declaration. That will be right resource declaration. Output variable, local variable, and well, output variables are going to be left till the end. And let's write them in this fashion so that it's clear what we're trying to write first. Node, local variable, resource, config variable. Now write resource declaration. I'll just write them in scope here. It's not config variable, local variable, and resource. There we go. The outputs, because actually we collect the variables, the output variables, into a dictionary at the end. So variables, don't do anything about them for now. We will collect them and get them later. Write variable, right. The reason I am writing it in scope so that it has access to begin scope and append line makes my life easier. Right, config variable. Local variable and write resource. Okay, that looks good. Config I will add later. The local variables, I will start with those because we immediately get append line will be var local variable dot name, and then the value is a syntax expression. That is where the fun starts, because we have to write syntax, write expression. Expression will be a syntax expression, and I'm guessing it will be recursive. It will take the append line function, which takes a string to unit. We'll take the begin scope function, which takes a function of unit to unit, returns unit. Write expression takes a string. No, it does not return a string. It will just write things in line. So it returns a unit. So write expression and I need another append, just append. Or maybe just append line, that would do. Write local variable. Write configurable and write resource. Okay, so expression is where it's at, starting with the basic expression that we have in the test program. Let's see, local variable is immediately a function invoke. It's immediately a function invoke, and it has arguments and returns an ID. Okay. Now that's Go code. The right expression take the string builder so that no, I would like to not care too much about these things. Okay, takes the append line, takes the begin scope, and takes append. Append line and append. I need to think about how to do that better, but let's start with it. So match expression with a syntax expression dot. Sometimes it's a bit annoying. Literal value expression, literal value, syntax value, string, int, null, and null. So once we have a string, we append missing number 2, okay. Close. Okay, so this is a literal value expression. We also have a syntax expression. Only it was working a bit better. Relative traversal expression, which is a relative traversal. Let parts is relative traversal. Why is it doing this? Because if I look at the generated program from this thing, Where is it? Tests, program JSON. No, the web server, it's this one. The local variable. Yes, local variable. It's a function declaration. Yeah, it relative traversal path takes the source, which is an expression, and dots it with just takes the source and gives you a traversal. Okay, let's see how that works. Only IntelliSense would help me. Okay, so source is an expression, which means we will just write it out. Write the expression, give it everything you have, append line, and begin scope. And then for each for part in relative traversal dot parts traversal, which is a traversal kind. Okay, match traversal kind. I think traversal attr name would be name. Traverse index. Index is an integer, so let me make a literal value out of it. And write another function that writes the literal value. That doesn't really matter. Literal index is this thing, and then syntax value integer index. Basically this. Anything else ignore for now, because these are the most common ones. For a relative traversal, we also have a scope traversal, which has a similar way. It's not absolute, it's scope traversal. So you will append the root name, and then you dot the things. That's a scope traversal. We have a function call expression, function call name, it's not the last one. I don't know. If it's the last one, I don't want to append a comma when I'm writing out the arguments of the function. Indexed. There we go. If, yeah, it's not the last one, then append this afterwards, which is exactly what I want. Then I want an object cons expression. Begin scope, because I want to indent whatever I'm doing here inside the object expression. Actually, append line. Oh, actually, append new, append line, then append line like this. Begin scope. Properties is a map, so I don't need the index. Pair.key. The value is itself an expression. Pair.value. And always write a comma afterward. Okay, that's a good start. Finally, let's write out also tuple cons expressions, which are lists basically. Anything else we stop. Items. Actually, we don't have to do that. Okay, that was quite a lot, and this won't even come out to be correct C#. But that's a good start at least. Because when it comes to function calls, we need to do a whole lot of things about them, because some specific functions need to be converted in a specific way, but right now we're just basically printing it. So let's see how that looks like. Hey, that looks awful. That looks really awful. I think because append should not indent. Only append line should indent. Yeah, append shouldn't know anything about indentation, it just adds. Actually, append line shouldn't do that either. Yeah, indent should be just another function to use. Okay, so we're passing out all these things here. And we're going to use that here. So right now only writing the local variable. Begin scope, indent. Begin scope, indent before you write anything. In here. Indent. Do not need to indent function call expressions, and the route after Russell should be fine. Okay. Did I mention that this is not valid C#? Well, this looks somewhat better now. There's almost no indentation. But that's okay. Yeah, I'll need to look into how to write a pretty printer for this, because well, it did do the dot at the end. I guess this should just. I will have to look into it, because this it's a bit trippy for me. Maybe I'm trying too hard with all passing of the indent and the scope functions. It started good. It started good with the begin scope, but then it started to become weird when I passed these things. But that's okay. I think I will look into it and see what's wrong. So for the time being, I'll just call it a day and see how far I can make it much nicer. You see, the thing is, when we have stuff like invoke AWS get AMI, what we're actually looking at is a function definition from the AWS AMI schema at the index module. So this should be actually AWS get AMI, yeah, something like that. Yeah, it should be something like this, but it's now this. So that's not the best. That's not the best, but again, it's fine. Can be handled later. So with that, I think I will call it a day. Thanks a lot for watching. Hope to see you next time, and have a good day. Bye bye.